Simple analysis of geography and then I would get into subject. Last year geography was make or break, right? Why? Because 18 to 19 questions, right? That means almost examiner he was having some revenge to be taken on those people whose geography is weak, right? And generally 75% of the aspirants will have geography weak. That is, for some reason I don't know, people will be lost in creating a new earth altogether. So in that context, I think those who had the toughness with respect to geography had a nightmare in clearing last year's paper. 18 to 19 questions, but the fundamental aspect of these 18 to 19 questions were from physical geography. Most of them. And most of them, if you had a grip on physical geography, last year paper was jujubi, nothing. Physical geography, basic polity, thoda idhar udhar current affairs, or thoda economy. Ho gaya paper khatam. Right? Now, looking at the trend, this year my anticipation is there's a lot of importance that is going to be on modern history. Right? They're going to come back with modern history this year. Right? My cycle again. Right? What is the reason for your anticipation? Pure observation. My anticipation again. Right? My anticipation this year is a good focus on current affairs. Modern history, good focus on current affairs. Right? And definitely we see tough economics. Tough. Right? Tough economics this year. Okay, so we'll see. We'll see. Nothing to worry. Right? We'll see when we have these variations how to attempt that particular paper. So on an average, if I see geography having convergence with environment, and I would never differentiate between environmental geography, environment and geography. I can't. Right? So on an average combination of these two sections, if I take, it is approximately 12 to 15 questions, which is again from geography, which we are having. And there are certain hotspots or there are certain definite areas in geography. इसका मतलब इससे बिना पेपर नहीं आएगा. That is fixed, right? उसमें तो one definite aspect that you would see with respect to this is vegetation. I can never have a question paper without vegetation. Impossible. I can never have a question paper without drainage system or river system of India. Impossible again. Right? Impossible again without having this. I can never have geography section without agriculture, especially to be very precise, agricultural operations and crops to certain extent. Right? And one definite area, I would never have geography question paper without planetary systems. Either it is stars, that is especially to be very precise, stars. Right? UPSC is inherently telling you that when you're seeing my paper, you're seeing them. So they would definitely imbibe this topic of stars in the question paper at any cost. So one definite section that we generally come across here is with respect to the planetary system, to be very precise, stars. Right? One more section that we see here is in the name of solar radiations. We would always see one or the other question coming from solar radiations with respect to geography. I can never see a question paper without solar radiation. It might be solar radiation or it might be light, whatever. Right? So that perspective is fundamentally seen in the context of geography again. Right? There is one more section which is extremely important from the side of geography, that is soils. Right? I would never see a question paper without soils. So what is categorically seen across is that definitely there are some hotspots. When you go back and refer to PYQs also, you will be able to see that these are all the kinds of important areas which are occurring from geography. Sometimes they would restrict it to one, sometimes they would restrict it to two. And one more important section is world climates. Right? I would dictate those 14 world climates towards little fag end of geography when we are doing. Every year we have one question. For example, this year we had Western marine type, that Then usse pehle we had equatorial. Usse pehle we had in 2021 savannas. So definitely every year we will have one or the other question from world climates, right? So this is one chunk, this is one section that we generally come across with respect to geography. For some reason last year they went on to ask on human geography, which is very weird, right? For example, TFR, total fertility rate. I don't know why people marked it wrong, right? No idea. But you have to understand that you can never mark those questions wrong. So last year, in fact, human geography was focused even in GS1 mains, even in geography section, there was an ample amount of focus on human geography. So in that context, you have to understand these are all some sections. Okay. Now, how are we going to deal with geography? Now, fundamentally, I would deal with geography. First, I would look into the physical. Right? First, I would talk about the physical. Then, I would look at the Indian aspect. Right? In Indian aspect, majorly it is with respect to the physiography. Right? Majorly it is the physiography and the climate part. Okay, right? In geography there is more of fact base, right? There is more of fact base. Now polity handouts are ready, right? There is one small change that was supposed to be made. We have done it. There are 3 handouts for polity. Each is of a size of 15 pages. I didn't want to make it voluminous. I just wanted to keep it as crisp as possible. It is only facts. All that you will have to do after you get those handouts is ratta marlo usko. Sit and by hand, because all those facts are extremely important at some section of time. Right? 15 pages I have made. So whole polity we would have 45 pages of facts. Right? Geography we have 42 pages of facts. It is also ready. I am splitting it to smaller sections and all of those will be given. Right? Maximum polity will come off today. Right? Because I was not well yesterday, I could not finish that small changes that were supposed to be done. At any cost, you would have polity at your disposal today, right? Geography, maybe 2-3 days, we would have that being done. Okay. So, with respect to this, we would see, and more than anything, we would see the factual dimension here in Indian. Now, from there, we would look at some basic terms of human, and along with basic terms of human, we would look at census, right? Although we see the same old census existing, census 2011, we are in 2025 almost. We are entering into December, right? Now we are in the Christmas month, everything is going on, right? So we see that census 2011, then some aspects of economic geography, majorly in economic geography, I would focus upon agricultural operations. Especially what is mulching, what is tillage, those fundamental dimensions I would focus upon. Right? I would not discuss about the data with respect to agriculture, but I would give you certain generalizations with respect to agriculture where this section would definitely have some convergence with economy part. Right? This section would definitely have some convergence with economy part. Okay, because we would have to look at certain superlatives, we would have to look at certain trends, we would have to look at certain aspects with respect to trade. So all of those dimensions would be discussed as part of that section. Is this clear? Right? So we would be dealing with that. Now, how will I be managing physical? Although I would discuss in the context of climate, oceans and geomorphology, but I would rather go more on the individual theme basis, right? If I am discussing about sun, I would discuss everything about sun. If I am discussing about the earth, I would discuss everything about the earth. If I am discussing about the wind, I would discuss everything about the wind. If I am discussing about oceans or water, I would discuss everything about water. In the sense, what is happening now, all of those clusters are going to be put in one area. Right? Such that what happens, now do not expect me to teach you a conventional geography. All those who expect me to teach whole geography in 4 or 5 classes, it's not going to happen. All that I will be doing is which is required for prelims examination. Because some people would expect me that, sir, you please teach me answer writing of geography in HAR. Right? That doesn't happen. Right? So one simple understanding is, I would go in a cluster approach, I would go in a thematic dimension here. Now, in general, whenever I start geography, I started with certain generalizations. As everybody knows, those who have attended already my classes. Generalizations in geography. Polity, how many generalizations did we have? 10. 10, how many? 8. How many? 8. ठीक है, right? Now first generalization in geography. Nothing is absolute, consistent, regular, steady, uniform. Nothing is absolute, consistent, regular, steady, uniform in geography. Right? Next. Every phenomena of geography or every concept of geography has an exception. Every concept of geography has an exception. Next. The naming in geography depends upon the direction and region of its origin. The direction and region of its origin. Next. Everything in geography is derived out of its name. Everything in geography is derived out of its name, right? So that means we would see that naming in geography is everything. We're going to have everything being derived from names. Next generalization. Any variation between northern hemisphere and southern hemisphere, any variation between northern hemisphere and southern hemisphere is due to variation in the distribution of land and water. Is due to variation in distribution of land and water. Right? Next. All concepts of geography is derived out of balancing the imbalance condition. All concepts of geography is derived out of balancing the imbalance condition. Next. Any phenomena which is natural is uncontrollable and anything can happen. Any phenomena which is natural is uncontrollable and anything can happen. That means anything can happen is the effects are extremely wide. Right? So that means anything which is natural will not have any control, and all those concepts which are not controlled will have a wide effects. Right? So that is another generalization that you are supposed to remember. Next. One more. Anything that is natural will have both natural and anthropogenic factors. Will have both natural and anthropogenic factors. Anything that is natural will have both natural and anthropogenic factors. Right? And all the concepts of geography, are relative in nature. All the concepts in geography are relative in nature. Is this clear? Right? Now, all of these generalizations would be self-explanatory to a larger extent. Right? For suppose if they say the tropical easterlies are steady. Are they steady? Right? Nothing can be steady. Nothing can be absolute. Right? Now, there is a steady decline in the temperatures along the depth of the ocean. Can it happen? No. Right? So that is first. The second, every concept of geography has an exception, definitely. Now when I see normal lapse rate, what is the exception for normal lapse rate? Normal lapse rate means as the height is increasing, the temperature is decreasing. The exception to this normal lapse rate is what? Temperature inversion. The exception to this normal lapse rate is temperature inversion. Exceptions to Indian monsoon is what, my dear? El Nino. Right? I see El Nino by itself is an exception. So in that context, we see that every concept of geography has an exception. Naming in geography depends upon the direction and region of its origin. For suppose, if I say tropical easterlies, I definitely know they are moving in which region? Tropical region. They are originating on which side? Eastern side. Right? If I am saying warm currents fundamentally means what? It simply means that these are originating in which region? Warm region. If they are originating in warm region, it should be equatorial? Yes. So that means what do I see? Anything that is named in geography will depend upon the direction of its origin as well as the region of its origin. When I am saying westerlies are not moving towards the west, but they are originating from the west. One simple. Everything in geography is derived out of its name. Right? One simple example that I keep saying is, what is climate change? Change in climate. Right? Change in climate here means what? Change in majorly the temperatures which are seen. One simple understanding. Or if I say jet streams which are moving like jet. When I say streams which are moving like jet is an entity which moves at high altitude, and jet is an entity which moves at high speed. So any stream which is moving at high altitude and any stream which is moving at high speed is what is called as jet stream. So anything that we see in geography is going to be definitely derived from name. Right? That is one very, very important thing all of us will have to remember. Variation between northern hemisphere due to variation in distribution of land and sea. I know that proportion of land is more in northern hemisphere than southern hemisphere. And proportion of water is more where, my dear, in the southern hemisphere than northern hemisphere. And I definitely see that in the context of northern hemisphere with respect to the land and water distribution, it is not so uniform. Now when it is not so uniform, I fundamentally understand that there are some changes which are inevitable. Now when there are some changes which are inevitable, I would see a lot of variations to be happening. So if I see that there are some bunch of variations which are seen to be happening, I see that those variations are fundamentally derived from what? Those variations are derived from the uneven distribution of land and water in the context of northern hemisphere. But whereas in the context of southern hemisphere, I see that with respect to southern hemisphere, I see there is more uniformity. Now I am not telling it is completely uniform, but it is more uniform. Why? Because every concept in geography is what? Relative in nature. Every concept in geography is relative in nature, and when you observe every concept to be relative in nature, I see that this is comparatively more uniform. When I say that this is comparatively more uniform, I see there are less changes. When there are less changes, there is less variation which is seen to be happening. So one simple understanding that you will have to have is variation between northern hemisphere and southern hemisphere will always have comparatively variation with respect to land and water. Next, when I look at sixth, all concepts of geography is derived out of the balancing the imbalance. Now, wherever I see something moving in geography, wherever I see some kind of movement in geography, I would see that this movement in geography will fundamentally happen because of imbalance which is existing. Now, for example, if I look at any of the circulations, or if I look at any of the wind system, I see that wind system is that system which is moving from high pressure to low pressure. Now, when a wind system is fundamentally moving from high pressure to low pressure, I definitely know it is an entity which is seen to be balancing the imbalance in the pressure condition. Now, when I say oceanic currents, I know that the oceanic currents would be moving with respect to imbalance in salinity, imbalance in temperature, imbalance in density. I see that whenever there is a variation with respect to this change, whenever I see a variation or whenever I see an imbalance with respect to this, I automatically see what is happening. There is some movement. And some movement, if it is happening, it is purely because of the imbalance that is seen to be existing in the system. Are you understanding this? Right? So that is one fundamental dimension. Next, any phenomena which is natural is uncontrollable and anything can happen. Now, for suppose, if I want to apply this principle to 2024 paper, the phenomena is with respect to the volcanic eruptions. Now, in volcanic eruptions, is volcanic eruptions natural or man-made? Natural. And when I see volcanic eruptions are natural, can I control something which is being emitted from volcanic eruptions? No. Now, should I speculate upon all of the things which have been given by UPSC? Impossible. So, anything which is natural is uncontrollable. I can never control something which is natural. Now, for suppose say, which of the following substances are released from forest fires? Can you control? No. Anything can get burnt. Anything can get burnt, and when something is burning, anything can be emitted. In environment, I would give you a generalization with respect to emissions, because every year we have one question on emissions. I would give you one generalization. How is it going to be varying if an organic substance is burning, if an inorganic substance is burning? I will tell you that. But in general, you observe, I can never control something which is natural, and I can never control something which is going to happen. Now, because of the earthquake, the digital board will be on fire. Possible. Why? Because it is natural. Anything can happen. So, in that context, you fundamentally observe, this is one generalization. Natural will have both natural and anthropogenic. Right? You please understand this. For example, climate change. In climate change, are we having only anthropogenic factors? No. We also have natural factors. We also have natural factors. For example, sunspot cycle, Milan-Covid cycles. Right? So, all of those dimensions are what? All of those dimensions are fundamentally natural factors. Next, all concepts of geography are relative. That means, if I see some high temperature here, I definitely know there would be some low temperature somewhere else. If I see some high pressure here, I definitely know that there would be some low pressure somewhere else. That is definite, that is inevitable. High temperature, high pressure, low pressure, any given day. Now, for suppose if I say there is say more clouds somewhere, I definitely would see less clouds somewhere else. So that is what I keep telling in class. Prati Laila ki oka Majnu. For every high pressure, there is a corresponding low pressure. I would definitely see a relative phenomena to be existing in the context of geography. You understand these basic generalizations, trust me my dear, geography is a cakewalk. There is no difficulty at all in geography, right? How many of you think geography is tough? Be open, don't worry. How come the proportion is so less? Achha, most of the proportion is the crowd which I taught. Oh. Right? In general, no ego. accordingly I would step down, right? If you're very comfortable, then I will increase my pace little bit. If you're no sir, nahi hoga, right? Along with the earth, our head also rotates, right? Then I would reduce the speed. Kya kare batao? Your choice. Because I'm okay with anything in this context. Because this fundamentally depends on sample size. How many of you are facing difficulty with geography? उसकी हिसाब से मैं कर लूँगा. How many of you feel physical geography is tough? That's it. Physical geography, बस. बहुत बढ़िया. ठीक है? No issues. Right. First we would start with planetary system. Weak geography, reduce speed. Weak geography, reduce speed. Right? Right? I did not start only, my dear. Okay. Reduce speed. I reduce. Right? Okay. Now when we look at planetary system, simple understandings, we see that one dimension that we come across is the arrangement. When we look at the arrangement, we know sun, and along with this we have a respective belt, which is the terrestrial planets, and here we have something called as asteroid belt. Then here we have something called as Jovian planets, right? And along with this, here we have something called as the Kuiper belt. And in this context of asteroid belt, we would have asteroids, and this is between Mars and Jupiter. This is between Mars and Jupiter, we have the asteroid belt. And after the Neptune, we fundamentally have the Kuiper belt, which is existing, and Kuiper belt is known for comets. Kuiper belt is known for comets. And any planet which is found out of the solar system, any planet which is found out of the solar system is what is called as exoplanet. Any planet which is found out of the solar system is what is called as exoplanet. And I see that if I find any zone outside the solar system, if I find any zone outside the solar system which is habitable in nature, is what is called as a Goldilocks zone. Goldilocks zone. Goldilocks zone is that zone where you find that habitable factors are seen to be existing. That is one simple understanding with respect to this. Now here, when we look at the sun, we see that sun is a uniform structure, one. And not only that it is non-uniform structure, you fundamentally observe it is a concentric structure. And when we look at the concentric structure, we fundamentally observe sun happens to have 6 layers, which is a CRC PCC. 6 layers, which is a CRC PCC. What is the CRC PCC? C is the core, R is the radiative zone, another C is the convective zone, P a photosphere, P is photosphere, another C is chromosphere, and the last one is corona. So in this context, what do you observe? You see that it is concentric in nature. It is seen to be experiencing different variations. And you also see the nuclear fusion reaction goes on within the sun. That means sun is nothing but a star. But when you look at the characteristic feature of the sun being a star, you have to fundamentally observe sun is a star. But the nature of the star that we see is sun is a dwarf star. Sun is a dwarf star, or sun is a average star. Sun is a dwarf star or sun is a average star, right? So that is one simple understanding with respect to sun. Now if we progress across in the concept of sun and the stars, now when we look at sun, as I told you, sun is a dwarf star, and we also see sun is known to have a temperature anomaly. Sun is known to have temperature anomaly, and when I look at temperature anomaly with respect to sun, that means what is this temperature anomaly? When I move from core to the corona, how is the temperature varying? When I move from core to corona, what is happening? I see that temperature is seen to be decreasing, but in the corona or near the corona, the temperature increases. Now that means what I generally know from the core, because core is the site of nuclear reaction. When I know that core is the site of nuclear reaction, as I progress, as I move away from the core, the temperature should be decreasing. But when I observe this dimension here, when you find that the temperatures to be decreasing, but suddenly near corona, there is an increase in the temperature which is seen to be happening. And the reason for such an increase in the temperature is what is called as alphan waves. Alphan waves are those waves which are resulting in the sudden increase in the temperature of corona. One. And when you look at these alphan waves are nothing but the magnetic emissions or the magnetic waves from the sun. The magnetic emissions or magnetic waves from the sun. So that is one more dimension that has to be understood here with respect to the temperature anomaly which is seen to be existing. Now along with this, we also see one more very, very important concept with respect to sun. That is the concept of sunspots. The concept of sunspots. We see sunspots are present in photosphere. Sunspots are present in photosphere. It is not only that these sunspots are present in photosphere, but we fundamentally also have to understand these sunspots are following sunspot cycle. And when you see the sunspot cycle is seen to be changing every 11 years. And when you look at this sunspot cycle which is seen to be changing every 11 years, I fundamentally see that there are two conditions with respect to this sunspots. One dimension that you see is there is something called as solar maxima. Solar maxima is where the sunspot activity is more. And there is something called as solar minima. And when we look at the solar minima, where we see that the sunspot cycle is reduced. When I see that the sunspot activity is less, I consider it to be solar minima. When I consider the sunspot activity is more, I consider it as solar maxima. So that is one simple understanding with respect to photosphere, right, and sunspot. And when you look at the sunspot as such, what is the characteristic feature of the sunspot as such? You see, the characteristic feature of the sunspot one is it is a region of high magnetic field. It is a region of high magnetic field. And not only that it is a region of high magnetic field, it is a region of comparatively lower temperatures. So any sunspot is nothing but a region of high magnetic field and a region of low temperatures. That means low temperatures comparatively with the outside condition which is seen to be existing. So that is one simple understanding with respect to high magnetic field and low temperature. And here what do we observe? During the solar maxima, we observe that the solar winds are seen to be increasing. That means because of the sunspot activity, we see that there is an increase in the solar winds or solar flares or solar magnetic ejections. Now always remember, these solar winds or solar flares or solar magnetic ejections are nothing but the magnetic emissions from the sun. magnetic emissions from the sun which are seen to be existing. Ma, are you all okay with this speed? Yes? Fine? Or should I increase? Reduce. Now if I reduce, Nidra potara. Forget about Nidra bodam. Geography will never get over in that speed. Is this fine? Yes? Right? Physical geography I will go at this pace. But human, economic and all, nothing much is there. Right? So I have that burden that I can happily go on for physical geography for 2.5 days. Right? So you need not worry. Okay? So when you see the sunspot activity, what do you categorically see? You see that one dimension is the solar winds are going to vary, the solar magnetic ejections are varying, the magnetic emissions. Now here, when I see this, when I want to experience or when I would want to see the impact of the solar winds or solar activity to a larger extent, we see that it would affect all the electromagnetic wave activities. It would affect all the electromagnetic wave activities where? On the earth. It would affect all the electromagnetic waves on the earth. So that is one simple understanding that you need to have with respect to the sunspot activity. Right? That means there are maxima, there is minima, there are sun cycle, there is photosphere, higher magnetic field, lower temperature. This is one dimension. Now once you understand this, we also see that I was referring that sun is nothing but a dwarf star. And when I look at this dwarf star, it fundamentally means that any star is nothing but a gaseous cloud or a dust cloud. Any star is nothing but a gaseous cloud or a dust cloud. It is also called as, it is fundamentally called as a stellar nebula. It is also called as a stellar nebula, where I see stellar nebula. Nebula is nothing but a cloud of gas. Stellar means what? Sun. Stellar nebula. And when you look at the stellar nebula, I know that the stellar nebula or the star can be of two types. One is the dwarf or average star. The other one is a giant star. One is the dwarf or average star, the other one is giant star. And when I look at the categorical difference between this dwarf star and giant star, what do we see with respect to the difference between the dwarf star and giant star? We observe, please write the way I am writing. Please. Right? Don't change. Right? Don't change. Please write the way I am writing, even though it is difficult. Okay? It is not so difficult. Okay? So when we see this dwarf star and giant star, what is happening in the context of dwarf star? I see that in the dwarf star there is less raw material. There is comparatively less raw material. It is not only that there is less raw material, the rate of nuclear reaction is less. The rate of nuclear reaction is less. Right? So that is another condition which is seen to be existing. And not only that, the end cycle of the dwarf star, will comparatively have less density. The end cycle of dwarf star will comparatively have less density. When I look at giant star, I see that in the context of giant star, there is more raw material. In the context of giant star, there is more raw material. And not only that there is more raw material, but the rate of reaction is extremely high, very, very high. The rate of reaction is very, very high. It is not only that the rate of reaction is very high, the end cycle of a giant star. The end cycle of a giant star is the one which is known to be having more density. The end cycle of a giant star is known to be having more density. Now one small thing that you will have to understand, that the end cycle of any star is fundamentally determined by a Chandrasekhar limit. And what is this Chandrasekhar limit? Approximately 1.4 times the mass of the sun. 1.4 times the mass of the sun. That means if any star whose mass is less than the 1.4 times the mass of the sun, and any star whose mass is more than 1.4 times the mass of the sun. When you look at any star which is known to be having of less mass than 1.4 times the mass of the sun, that is what is considered as a dwarf star. And whereas this is what is considered as giant star. Giant star. And you always have to understand, any star which is known to be having of this particular mass, where you observe that star is less than 1.4 times the mass of the sun, this can never be a black hole. This can never be a black hole. Right? The star which is having less than 1.4 times the mass of the sun can never be a black hole. But whereas for a particular star to become a black hole, it has to satisfy this condition where the mass of the star has to be more than the 1.4 times the mass of the sun. 1.4 times the mass of the sun. So that is one simple understanding that you are supposed to have with respect to the stars. Now here, once you understand this, let's continue our discussion here. When you see this, the dwarf star which is seen to be existing, the maximum stage the dwarf star can reach is white dwarf. The maximum range that it can reach is white dwarf. But whereas when I look at giant star, the giant star can reach something called as a supernova. The giant star can further reach something called as, either in two dimensions, either a neutron star or either a black hole. Either a neutron star or a black hole. So that is one simple understanding. A giant star can become supernova, and a supernova can become a neutron star and a black hole. Right? This is fundamentally the life cycle of a star. Fundamentally the life cycle of a star. Every year some or the other question is coming on this. I don't know why UPSC is obsessed. Right? So we see that this is one simple arrangement. And not only this, here we observe that when I see this dimension here in the context of white dwarf, you always remember that the maximum stage sun can reach is white dwarf. The maximum stage sun can reach is white dwarf. That means, just write down one line, sun can never be a black hole. Sun can never be a black hole. Why sun can never be a black hole? Because of sun is a dwarf star. Now when sun is a dwarf star, sun can never be a black hole, and in that context we are seeing this dimension white dwarf and black hole. Now once you understand this dimension of white dwarf and supernova and neutron stars and black hole, I see that in the context of neutron star, a neutron star is one which with respect to a gaseous substance which is existing, and it is not only a gaseous substance, but you see that it is dense. It is not only gaseous substance, but it is dense. And we observe that a neutron star can be a magnetar, or neutron star can be a pulsar. Neutron star can be a magnetar, or neutron star can be a pulsar. And when I look at this neutron star which is a magnetar or a pulsar, magnetar is that star which has a large magnetic field. Magnetar is that star which has large magnetic field. We are calling it as magnetar. And whereas when I look at the dimension of pulsar is that star which is pulsating in nature. It is pulsating in nature. It is not only pulsating in nature, but it is also radiating in nature. It is radiating in nature. If I have to simply show you a diagrammatic representation of a pulsar, pulsar would look like something like this. That means from the poles of the star, from the poles of the neutron star, when I see some kind of radiations which are pulsating out, I call that fundamental dimension as what, my dear? I call that fundamental dimension as pulsar. I call that fundamental dimension as pulsar. Pulsar is nothing but the pulsating star. Pulsar is nothing but the pulsating star. But I also see that a small extension of this discussion is, when I look at this neutron star, I know that neutron star is a star. Neutron star is a star. But I also see that similar variant of this is nothing but a quasar. Nothing but a quasar. And you have to understand, quasar is again, it is known to have high density. It is not only known to have high density, but you also see a quasar is not a star. Quasar is not a star. Quasar is not a star. Quasar is known to have high density, and quasar is also illuminating in nature. It is an luminous body. It is a luminous body. Just because it is luminous body, it is not a star. So that is why we are calling it as what, my dear? Quasar is nothing but a luminous body which is not a star, which is known to have large density. And I also see similar variation with respect to quasar. The variation with respect to quasar is blazar or blazer. Now when you look at this quasar and blazer is also not a star. Blazer is also not a star. And not only that blazer is also not a star, you also have to fundamentally understand that this is comparatively less dense than quasar. This is comparatively less dense than quasar. It is comparatively less dense than quasar. So that is one simple understanding that you need to have with respect to neutron star, quasar, blazar. And one small variant of this that we have to understand here is Cepheids. Now when we look at Cepheids as such, we see Cepheids is again a star. Cepheids is again a star. But what is the fundamental variation with respect to Cepheids as such? We see that Cepheids is nothing but that which is fluctuating in nature. That which is fluctuating in nature. It is fluctuating in nature with respect to the extent of brightness. It is fluctuating with respect to the extent of brightness. And not only fluctuating with respect to extent of brightness, but it is also fluctuating with respect to the extent of density which is seen to be existing. So one dimension that you would have to understand is Cepheids, star, fluctuating brightness and density. That means Cepheids is a star which is illuminating, but with fluctuating brightness and fluctuating density which is seen to be existing. So these are all some of the variants that have to be understood in the context of a star, a life cycle of a star. Maximum this one page will do all the business that you want. You don't need to worry at all. Giant star, dwarf star, white dwarf, black hole, neutron star, magnetar, pulsar, quasar, blazar, Cepheids, right? And sun can never be a black hole. Sun can never be a black hole. And what is a black hole? And I see that black hole is nothing but that which is known for its high density. It is so dense that even light cannot escape. It is so dense that even light cannot escape. I see that along with black hole there is a kind of point of singularity which is experienced. There is a point of singularity which is seen to be experienced in the context of the black hole. And not only this dimension of point of singularity which is seen to be existing with respect to black hole, you also see the boundary of the black hole is what is considered to be the event horizon. Event horizon is the boundary of the black hole. Event horizon is the boundary of the black hole which is demarcating the boundaries of this black hole. And that is what? That is the first point from where I can see some sort of reflection of the light if the light is sent to the black hole. But otherwise, in general, you would observe that the black hole would never allow light to escape. The density of the black hole is very high. Right? This is one simple understanding with respect to the dimensions of star. Now continuing with our discussion on sun. Continuing with our discussions on sun, we were seeing that there is something called as sunspot activity, there is something called as solar winds. And as I told you, the sun would be emitting these solar winds. And as the sun is seen to be emitting these solar winds would fundamentally affect what? These solar winds would fundamentally affect some dimension which is seen to be existing, especially the electromagnetic waves. Especially the electromagnetic waves would be, or whatever sort of electromagnetic wave operations. That means what? Like communication, like satellites, like internet, like electricity, right? All of these dimensions would be affected with respect to the earth. And not only that, we see that there is a special layer which is seen to be existing around the earth. And when you look at the special layer which is seen to be existing around the earth, this special layer is what is called as the magnetosphere of the earth. This special layer is what is called as the magnetosphere of the earth. And you observe that these are various layers which are seen to be existing. And when you observe this magnetosphere is nothing but the bulletproof of the earth. Magnetosphere is nothing but the bulletproof of the earth. And you observe that these various belts of magnetosphere are what are called as Van Allen belts. These belts of magnetosphere are what are called as Van Allen belts. These Van Allen belts, or these different layers of the magnetosphere, are going to fundamentally shield the earth from the solar winds. Are fundamentally going to shield the earth from solar winds. So the magnetosphere, which are different layers, which is shielding the earth, and these are otherwise called as what? Van Allen belts. These are otherwise called as Van Allen belts, and you fundamentally observe this is going to shield, and that is the magnetosphere dimension. And here, depending upon the solar winds, we fundamentally observe there is an activity which is seen to be going on along the polar regions of the earth. And those are what are considered to be the polar lights. Those are what are considered to be the polar lights. And they are what are considered to be polar lights, and they are nothing but auroras. They are nothing but auroras. And auroras in the northern hemisphere is what is called as aurora borealis. And auroras in the southern hemisphere is what is called as aurora australis. Right? Aurora australis. And these polar lights will again fundamentally depend upon solar winds. So that means if I have to summarize this supply chain in this context, very simple, that I see that sun in photosphere will have some dimensions called as sunspots, and depending upon these sunspots I fundamentally see the extent of solar winds which are ejected, and this would affect the electromagnetic wave activity on the earth. And not only that it is affecting the electromagnetic wave on the earth, but it is also going to affect some phenomena called as polar lights. Some phenomena called as polar lights. Polar lights, otherwise aurora borealis and aurora australis. Is this clear? Yes? So that is one simple understanding with respect to sun. Right? Now, the next thing that we will have to see is our beautiful earth. Right? You want to see it or not? You will have to see it. There is no other go. Okay? Earth. Usse pehle we will have to see some superlatives which are seen to be existing. Right? One simple superlative is the smallest planet is what? The smallest planet is Mercury. The densest planet, Earth. Right? Largest planet, Jupiter. Highest number of satellites, Saturn. Right? Which are known for retrograde rotation. U and V. Uranus and Venus. Right? Which is considered as Earth's twin. Venus is considered as Earth's twin. Right? And there is something called as ecosphere. And you see two planets are considered as part of ecosphere. One is the Earth. The other one is Mars. One is the Earth, the other one is Mars, right? One is with respect to Earth and the other one is Mars, right? So this is one simple understanding that is supposed to have with respect to some of the superlatives. But in general, when we look at Earth, we know that Earth is more of a terrestrial planet. Earth is more of a terrestrial planet. We know Earth is more of an oblate sphere, or this is a spheroid. It is oblate sphere or spheroid. And we observe in this context of the Earth, when we say it is oblate sphere or spheroid, we fundamentally observe the flat poles and bulged equator. And majorly we see this flat poles and bulged equator because of what matter? Because of the rotation. Because of the rotation, and we also see something called as the tidal forces which are seen to be existing. Because of the rotation and because of the tidal forces which are seen to be existing, we see that it is an oblate sphere, it is spheroid, it is spherical in nature. And not only that dimension, we also see in the context of the Earth, we see that Earth fundamentally has two kinds of movement. One is the rotation, the other one is a revolution. And when we look at this rotation and revolution, whatever is the rotation that is seen to be happening, that is seen to be happening on a tilted axis. Rotation does not happen on a linear axis, but rotation is seen to be happening on a tilted axis. And we observe the revolution is seen to be happening not in a circular orbit, but elliptical orbit. Right? Elliptical orbit, where you see this revolution is seen to be happening. And we observe that because of the rotation of the Earth, we see there is a phenomena called as a day and night. We also see that there is a phenomena called as day and night when we observe with respect to the rotation. And when we see it with respect to the revolution, we see that this is what is resulting in the length of day and length of night. The length of day and the night are varied with respect to the revolution. And not only that dimension, we also see that in the context of revolution perspectives, we see that the relative position with the sun, changes. The relative position with sun changes. When you observe this relative position with sun changes, one is what is the perihelion, the other one is aphelion. The one is the perihelion, the other one is aphelion. And when you look at perihelion, perihelion fundamentally is the closest point. And it is seen to be occurring somewhere around January 3rd. I see that perihelion is what is the closest point, and it is seen to be occurring somewhere on January 3rd. But whereas aphelion is the farthest position, and it is somewhere seen to be occurring somewhere in July 3rd. I know helio. Helio means what? Sun. Helio means what? Sun. And I see this perihelion and aphelion. Perihelion happens to be the closest. It is seen to be somewhere existing with respect to January 3rd, but whereas in the aphelion it is the farthest, it is seen to be present with respect to July 3rd. Now once you understand this basic dimension here, I know in the context of Earth, I fundamentally observe, in the context of the Earth, I fundamentally observe there are some reference lines which are seen to be existing. And these reference lines are imaginary in nature. And these imaginary in nature are angular in nature. These are reference lines, these are imaginary, these are angular. And these angular can either be horizontal or these can be the vertical. And when I see this horizontal and vertical, one simple understanding, the horizontal angular imaginary reference lines are what are called as latitudes. And whereas when we look at the vertical imaginary reference lines are what are called as longitudes. Right? That is one simple understanding with respect to latitudes and longitudes. Latitudes are nothing but the horizontal reference angular lines and imaginary lines. But whereas longitudes are what? Vertical imaginary lines which are seen to be existing. Now once we understand this, we see that longitudes are majorly used only for the purpose of time. Only for the purpose of time. And we also observe for every 1 degree variation there is a variation in 4 minutes. And we see that as we move east, we need to add as we gain time. As we move west, we need to subtract because we lose time. And this is fundamentally seen to be happening. Why? Because Earth rotates in which direction to which direction? West to east. Earth rotates from west to east direction. Right? So generally this is what is the rotation process that is seen with respect to the most of the planets. But whereas in retrograde rotation I see what? In the context of retrograde rotation it is the other way around which is seen to be existing. So you observe that Earth rotates from west to east with respect to the longitudinal dimensions. And not only that, I see there is one imaginary line called as international dateline. And I see this imaginary dateline which is seen to be existing in the imaginary or the international dateline. Along the movement of the international dateline, that means if this is then ideal, I see that when I move from this, when I move across ideal, there is no change in time, but there is change in date. There is no change in time, but there is change in date. That is why we are calling it as what? That is why we are calling it as international dateline. That is why we are calling it as international dateline, because there is no change in time and there is only change in date which is seen to be happening, that is international dateline. And I also observe that this is not uniform. This is not uniform. And majorly when you observe this as it is not uniform, you observe that ideal is passing through the Pacific Ocean. Ideal is passing through the Pacific Ocean. And I see a kind of deviation that is seen to be happening with respect to the ideal or the international dateline over the Aleutian Islands or Bering Sea. Either over the Aleutian Island or over Bering Sea, you fundamentally observe there is seen to be a kind of deviation that is seen to be existing in the context of international dateline. So with respect to ideal, it is not uniform, it is moving through Pacific Ocean and it is all moving through the water. I see that imaginary line is what is seen drawn across the water. So that is one simple understanding with respect to longitudinal perspectives. Now when I look at, apart from the longitudinal perspectives, when I see the latitudinal perspectives, you observe that in the context of latitudinal perspective, I see that whole of the temperature distribution is seen with respect to the latitudinal perspective. And not only the temperature distribution, but the weather, the ocean concepts are seen with respect to the latitudinal perspective. All of the concepts of weather, all of the concepts of climate, all of the concepts of ocean are seen to be moving across the latitudinal positions. And we observe it fundamentally divides the earth into north and south, and that is where we see there is a reference latitude which is considered to be equator. There is a reference latitude which is considered to be equator, and I see the range of latitude is 0 to 90 degrees north or south. But whereas in the context of longitude you fundamentally observe 0 to 180 degrees east or west. I see when there is an east to west orientation, I fundamentally observe it is the dimension with respect to longitude, but when I see north to south, it is a dimension with respect to latitude which is seen to be exist. So I observe there is a variation which is seen to be existing in the context of the earth. I see when I observe this kind of variation that is seen to be existing from 0 degrees, I know 0 degrees is the equator and 90 degrees is the poles. And when I move from equator to poles, when I move from equator to poles, I fundamentally see there are multiple variations which are seen to be existing. One particular variation that I see is the temperature decreases. The water vapor decreases. One is the temperature decreases, the water vapor decreases, a biodiversity decreases. Right? Temperature decreases, water vapor decreases, the biodiversity decreases. A Coriolis force increases. Coriolis force increases. Why Coriolis force increases? Because Coriolis force is that force which is resultant because of the rotation of the earth. It is because of the rotation of the earth, And it is not only because of the rotation of the earth, you fundamentally observe it is nothing but a deflecting force. It is nothing but a deflecting force. That is what is one simple understanding with respect to Coriolis force. You see, it is because of rotation and it is a deflective force. And when you observe certain dimension with respect to Coriolis force is proportional to V naught sine theta. Coriolis force is proportional to V naught sine theta, and when you observe this V naught sine theta, V naught is nothing but it is the velocity of the object. It is not velocity of the earth but velocity of the object. And when you look at theta, theta is nothing but the angle of latitude. Theta is nothing but the angle of latitude which is seen to be existing. So Coriolis force is proportional to V naught sine theta. That means higher the speed of the wind, I see higher the Coriolis force. Higher the latitudinal angle, I see higher the Coriolis force. That is one dimension. There is one more small variation as I move across this. I fundamentally observe the speed of rotation. The speed of rotation. What is happening to the speed of rotation? Decreasing or increasing? I see the speed of rotation decreases. The speed of rotation fundamentally decreases. And not only that the speed of rotation is seen to be decreasing, I see the radius is also seen to be decreasing. I see more radius along the equator compared to the poles, because I see fundamentally what is happening. It is flattened poles. So one dimension is the speed of rotation is reducing as I move from equator to poles. And not only the speed of rotation is reducing, I also see that the radius is also reducing. That means I can simply say the radius along the equator is greater than the radius along the poles. The radius along the equator is greater than the radius along the poles. One simple understanding. One more, depending upon this, I see the level of gravity is also seen to be decreasing. The level of gravity is seen to be increasing. The level of gravity is seen to be increasing. Why? Because I know gravity is inversely proportional to radius square, and I observe the gravity over poles is more than the gravity over equator. I see the gravity over poles is more than the gravity over equator. That means as I am moving from equator to poles, I observe that the gravity is also seen to be increasing. I observe that the gravity is also seen to be increasing. So one simple understanding that you will have to have here is what? There are multiple variations which are seen to be happening across the latitude. There are multiple variations which are seen to be happening across the latitude. And one more small variation that you have to observe here is the height of tropopause. The height of tropopause is seen to be decreasing as you move from equator to poles. The height of tropopause is seen to be decreasing as you move from equator to poles. Is this clear? The height of tropopause is seen to be decreasing as you move from equator to poles. And to a larger extent, I also observe the number of clouds is also seen to be decreasing. The extent of cloud formation is also seen to be decreasing. The extent of cloud formation is also seen to be decreasing as you move from equator to poles, right? So that is one simple dimension that you would have to understand here, right? Next, one more thing that you would have to understand with respect to this. One is the tropopause, the gravity, radius, speed of rotation, temperature, water vapor, biodiversity, Coriolis force, and the cloud. And one more small difference that you see, that the probability of atmospheric instability. The probability of atmospheric instability. The probability of atmospheric instability is seen to be happening what, my dear? The probability of atmospheric instability is also seen to be decreasing. I see more probability of atmospheric instability to be existing over this equator region and along the tropical regions. But as I move along, what is happening? Along the poles, I find that the atmospheric instability is seen to be reducing. It fundamentally means I see that there is more probability of the calm regions which are seen to be existing. I see there is more probability of the calm regions which are seen to be existing. So that is one simple understanding with respect to this dimension. Are you understanding this? Yes? Just take 2 minutes and revise. Please. 2 minutes and revise, and then we'll get back. Please. Now, my dear, I already told you, don't expect me to go very slow. Right? Now, if it is rocket speed, jet speed, if you observe, I am repeating every point 3 times. Yes? Then, right, morning you are not away from your slumber, you are not woken up, and you say I am on a rocket speed, not justified. Right? आपको adapt करना पड़ेगा because this is a revision program, and you don't expect me to teach you in a conventional way, because all of these what I taught you will be taught in 6 to 7 classes of general geography. Right? If your subject is weak, I can't do anything. Right? Whatever I am maximum trying here is what? To open up your conceptual clarity here. Right? So we are consolidating, and you will have to adapt. So please take 2 minutes and revise. Write down. Keep this table. Factors, corresponding effects. Factors, corresponding effects. First, latitude. Latitude. Higher latitudes, lower temperature. Higher latitudes, lower temperature, and maximum temperature in subtropics. Maximum temperature in subtropics, approximately 20 to 30 degrees. Maximum temperature in subtropics, approximately 20 to 30 degrees. Here in bracket you write cloudlessness. Cloudlessness. In bracket you write cloudlessness, comma, large rate of evaporation. Large rate of evaporation. Cloudlessness and large rate of evaporation. Next. Second, altitude. Altitude. Write down. Height increases, temperature decreases. Height increases, temperature decreases. In bracket you write air is dense near earth surface. Air is dense near earth surface, comma, contains more water vapor. Contains more water vapor and dust particles. Contains more water vapor and dust particles. Next, third, rotation and revolution. Rotation and revolution. Day and night. Day and night, comma, tidal bulging. Day and night, comma, tidal bulging, comma, seasons, comma, seasons. Next, inclined axis. Inclined axis. Variation in day and night. Variation in day and night, comma, seasons. Variation in day and night, comma, seasons. Next, a distance from the coast. Distance from the coast. Write down. Closer to the coast. Closer to the coast. Moderate the weather condition. Moderate the weather condition. Away from the coast. Away from the coast. Extreme temperatures. Away from the coast, extreme temperatures. In bracket you write continentality. What is continentality? What is continentality? A simple understanding is what? For suppose if I say this is a region, right? I know that all along I find my water to be existing. For suppose I know that the concept of specific heat, right? The specific heat of land is less than specific heat of water. That means this specific heat is determining the rate of cooling and rate of heating. Lesser the specific heat, faster is the rate of heating and cooling. More the specific heat, it fundamentally takes more time, right? So depending upon the specific heat, I see the time taken to cool and warm is going to be determined. Lesser the specific heat, lesser the time. More the specific heat, more the time. That I need more time to cool, I need more time to warm. That is one condition that I need to understand in the context of the specific heat. Now depending upon this variation with respect to specific heat in the context of warming and cooling, my fundamental understanding at this context would be that during the day, I observe that the land gets heated faster. When the land is getting heated faster, I see that the temperature of the land is more. When the temperature of the land is more, I would definitely observe that the pressure over land is less. Why? Because I definitely know there are some relations that there is an inverse relation that is seen to be existing with height. This is nothing but what? This is nothing but normal lapse rate. As the height increases, the temperature decreases. There is another relation that is seen to be existing, that pressure is inversely related to temperature. That means higher the temperature, lower the pressure, lower the temperature, higher the pressure. There is one more relation that I see, pressure is also inversely related to height. That means as the height increases, what is seen to be happening, my dear? Pressure decreases. As you see that as the height increases, the pressure is seen to be decreasing. So that is one simple understanding that you would have to have with respect to this, right? Temperature inverse relation, pressure inverse relation, and pressure and height inverse relation. So that means I see that as I find the specific heat to be more, I find that the temperature of the land increases. When the temperature of the land increases, I would fundamentally see that the pressure reduces. Right? When the pressure reduces, that means there is a low pressure condition over what? Over the land, and there is a corresponding high pressure condition on water. Why? Because I definitely know it is all relative phenomena. Higher the pressure or higher the temperature, lower the pressure, lower the temperature, higher the pressure. And I also know that for every low pressure condition here, there is a corresponding high pressure condition there. And I see there is a relative low pressure on the land, I would see there is a relative high pressure on the water. And automatically what is going to happen? I know that wind is going to move from high pressure to low pressure. And that wind which is originating on the water is what is called as sea breeze. That wind which is originating on the water, which is called as sea breeze. So that means I definitely know during the day what is happening. During the day there is sea breeze. During the day, land is getting heated faster because of specific heat. As it is getting heated faster, there is a lower pressure, correspondingly high pressure on the sea. And when you see that with respect to correspondingly high pressure over the sea, what do you observe? I know that the wind movement happens from high pressure to low pressure. And when the wind movement is seen to be happening from high pressure to low pressure, automatically what is happening? Because of this movement, as it is originating on the sea, I know the nomenclature says what? The naming in the geography will depend upon the region and the direction of its origin. And the region of its origin is where, my dear? Region of its origin is in sea. Sea breeze. Right? And that means during the night what I would have? Land breeze. During the night I would have land breeze. During the day I would have sea breeze. Sea breeze during the day and land breeze during the night. Now once you understand this, what is seen to be happening is because of this continuous exchange of land breeze and sea breeze. Because of the continuous exchange of land breeze and sea breeze, what do you categorically see, my dear? Because of the continuous exchange of the land breeze and sea breeze, what do you observe? All the temperatures along the coast are going to be moderated. It is going to be moderated. Why? Because of the continuous exchange of the breeze, continuous exchange of the wind. The reason why there is a continuous exchange of the wind is what? There is some imbalance, and this imbalance is going to be covered up, and this imbalance is going to be covered up with the continuous exchange of land breeze and sea breeze. Now what is happening is when I move from this particular point to the interiors of the continent, when I move into the interiors of the continent somewhere at this point, what is seen to be happening in the interiors of the continent? I find an issue in the interiors. Why? Because this particular land breeze and sea breeze will not be able to reach up to this point. Now when this land breeze and sea breeze is unable to reach up to this point, why? Because it is far away. Right? You would definitely never experience coastal winds in Telangana. Can you? Although our Honorable Chief Minister had given a coastal boundary to Telangana, it's a different issue. Just because Andhra Pradesh was having it. Right? So it's a different issue. So, right? But will I experience the coastal winds in Telangana? Impossible. Why? Distance. Right? I don't have a coastal boundary in Telangana. When I don't have a coastal boundary in Telangana, I am never experiencing these coastal winds. Why? Far away from the point. So what is seen to be happening? I will not be able to experience the moderating effect of this land breeze and sea breeze. I will not be able to experience the effect of this land breeze and sea breeze somewhere in the interiors of the continent. Why am I not experiencing somewhere in the interiors of the continent? Because it is far away. As I am unable to experience this, I see that in the interiors of the continent there are some extreme temperatures. In the interiors of the continent I see there are some extreme temperatures. And such a phenomena where you observe the extreme temperatures to be existing somewhere in the interiors of the continent is what is called as continentality. That means continentality is a phenomena with extreme temperatures in the interiors of the continent. And it is in the interiors of the continent due to what? Due to the absence of the moderating effect of land breeze and sea breeze. Due to the absence of the moderating effect of the land breeze and sea breeze. So that is one simple understanding with respect to distance from the coast. Right? That is one simple understanding. That is with respect to this dimension. Now once you understand this perspective here with respect to the distance from the coast, you also have to understand that there is another factor which is seen to be existing, that is nature of land and water. Another aspect that you will have to see is with respect to nature of land and water. Now when you look at this nature of land and water, I know that the fundamental variation is what, my dear? Due to variation in a specific heat. The fundamental variation is due to variation in specific heat. Right? Due to variation in specific heat, you would find this dimension. There is another factor which is affecting the temperature. There is another factor which is affecting the climate or temperature, that is albedo. Albedo. What is albedo? The reflective capacity of a surface. Albedo is nothing but the reflective capacity of a surface. Right? And depending upon the albedo also, we find that there is a variation which is seen to be happening with respect to climate. Right? Now that means if a particular body is able to reflect more, what is going to happen? If a particular body is going to reflect less, what is going to happen? In simple understanding, if I have to tell you that variation, that when the reflective capacity is more, I see it is cooled faster. When the reflective capacity is less, when the reflective capacity is less, right? When you find that the reflective capacity is more, it is cooled faster. When the reflective capacity is less, you see it is warmed or it has a heating effect. It is warmed or it has a heating effect. Right? So that is one simple understanding with respect to albedo climate, the reflective capacity increasing and the reflective capacity decreasing. One. Now, not only the dimension with respect to albedo, the eighth dimension that we see is with respect to the cloud cover. With respect to the cloud cover. Now, when we look at cloud cover, I see that there are different types of clouds which are seen to be existing. When I look at these different types of clouds which are seen to be existing, one is a high cloud, the other one is a low cloud. Right? One is a high cloud, the other one is a low cloud. And when I know this high cloud and low cloud, it is fundamentally depending upon the height of its formation. Right? To be very precise, if it is forming above 6 kilometers, I am calling it as high cloud, and if it is forming below less than 2 kilometers, it is what is called as low cloud. I see a corresponding variation with respect to high cloud and low cloud, that is with respect to more than 6 kilometers and less than 2 kilometers. Now that means I observe that whenever I see there is a high cloud or a low cloud, one simple understanding for us, because I know that what is happening when I move from one particular point to the other, what is generally seen to be happening? I see that the water vapor is seen to be decreasing. And not only that the water vapor is also decreasing, what is also decreasing? The temperature is also decreasing. Don't you think this particular tendency as I am moving across the altitude is very similar to the moving tendencies across the latitude? Now when we look at these tendencies, I see the temperature, I see the water vapor, I see the biodiversity. All of them decreasing across the latitude. In the similar manner, I also see all of them decreasing across the altitude. So in simple line, just write down one line. Altitude mimics latitude. Altitude mimics latitude. When I say altitude mimicking latitude, what you have to categorically understand, that means whatever is the phenomena that is happening with respect to latitudes, a similar kind of phenomena is seen to be happening with respect to altitudes. So altitude mimics latitude. Mimicking means what? Similar phenomena. Right? So that is one simple understanding that you have to have. Now with that basic understanding, I know when I see a high cloud is nothing but a thin cloud. And low cloud is nothing but a thick cloud. I know that high cloud is nothing but a thin cloud, and low cloud is nothing but a thick cloud. Why? Because there is variation in what context? In the water vapor. And because of this, what do you observe? The thin cloud is more absorbing in nature. The thin cloud is more absorbing in nature, whereas the thick cloud is more reflecting in nature. The thin cloud is more absorbing in nature and the thick cloud is more reflecting in nature. When I see this thick cloud to be more reflecting in nature, That means, will it be cooling or warming? It will be cooling. Here it will be warming. So I see that high cloud is a thin cloud which is absorbing in nature, and low cloud is a thick cloud which is reflecting in nature. And correspondingly, I would see that there is a variation which is seen to be existing in the context of temperatures. Corresponding variation with respect to temperatures are seen here, right? And not only that dimension which is seen to be existing, but another factor which is seen to be existing in the context of the climatic conditions is, I would say, the wind systems or some sort of circulations like jet streams. Some wind systems or some sort of circulations like jet streams. Right? Now here when you look into this wind systems and something which is with respect to jet streams, I see that in the context of wind system, one simple parameter is anything which is onshore winds. Anything which is seen to be onshore winds. Onshore winds means what, my dear? Incoming winds or outgoing winds? Incoming winds. Onshore winds. I see that onshore winds would fundamentally result in wet conditions, or would fundamentally result in favorable conditions for rainfall. Will fundamentally result in wet conditions and will fundamentally result in favorable conditions for rainfall. But whereas when I look at offshore winds, I see that offshore winds are fundamentally seen to be existing with respect to where this is what is going to result in the dry conditions. This is what is going to result in dry conditions, because you observe that the moisture is going to be taken away. The moisture is going to be taken away, the moisture is going to be carried away. So offshore winds will fundamentally result in dry conditions, but whereas onshore winds will fundamentally result in wet conditions. Is this clear? Right? Next. I also see another parameter which is affecting the climate in a particular region is in the context of rainfall. Especially, to be very precise, orographic rainfall. Especially to be very precise, orographic rainfall. When you observe this orographic rainfall, I know that this is one particular region where the condensation process goes on. And when I observe this condensation process is going on, this is what is considered to be a windward region. That is what is considered to be a windward region. And not only that, that is what is considered to be a windward region, but I also see this is rain-bearing region. That is rain-bearing region. Rain-bearing region means that is where I see an element of rainfall which is seen to be existing. And I definitely know rainfall moderates the temperature. Always remember that rainfall moderates the temperature. But whereas when I look at this particular region, I see that there is one simple dimension where I observe there is descendance of dry winds. Now because of which this particular region is what is called as a leeward site. And this is what is called as the rain shadow region. This is what is called as the rain shadow region, and that is what is understood to be leeward site. And that means this is the condition where I would find dry conditions to be prevalent. Dry conditions to be prevalent where this particular region is devoid of rainfall. There is no rainfall which is seen to be happening in this particular region. Right? And one more condition that I would see what climate is being affected by, I see in the context of ocean currents. Are you observing the tendencies? What are we doing? What is the cause? What is the effect? What is the cause? What is the effect? We are transitioning across various subjects. And what are we looking at? We are only looking at the climate perspective. Right? Once you understand this, business is easy. Okay. So ocean currents, I know that there can be two types of ocean currents. One is the warm current. The other one is the cold current. One is the warm current. The other one is the cold current. Now when you observe this warm current and cold current to be existing, what do you observe? Warm current fundamentally moderates the climate. Moderates the climate. That means brings rainfall to dry regions, and not only brings rainfall to dry regions, it brings warm conditions to cold regions. It brings warm conditions to cold regions, right? Warm conditions to cold regions, rainfall to dry regions, right? That is what is seen in the context of warm currents. Now, whereas when we look at cold currents, cold currents fundamentally result in dry climates. Cold currents fundamentally result in dry climates. And not only that the cold currents will fundamentally result in dry climates, but we also have to understand in the context of cold currents that these would have a desiccating effect. These would have a desiccating effect. A desiccating effect means what? Drying effect, desiccation. That means when you completely remove the moisture from a particular region or from a particular substance or an entity, you call it as desiccating phenomena. Right? Please revise geography and come, especially your physical. Right? I know most of you will face some issues with physical, but revise the physical and come, accordingly we would finish the business. Is this clear? Yes? Fine, my dear. Thank you.